Hello friends, welcome to VK lectures. In this lecture we will be discussing about how to find the integration of a complex function. Here we have the integral from a to b f of x dx. This is a line integral along a line of the function f of x. Now when you come to the complex number z equal to a to b, f of z dz, this a and b are complex numbers. It's also line integral along the curve connecting a and b. Now if this f of z, this particular f of z is analytical, then it is independent of the curve. No matter what is the curve, integral from a to b f of z dz will be independent of the curve, and it depends only on the end points, which is a and b, and this would happen only if this f of z is analytical. Evaluate the integral from z equal to 0 to z equal to 1 plus I. The f of x or f of z is x square minus iy dz. Now two questions are there. We have to find the integral along y equal to x, this is the one curve, and also along y equal to x square. Now let's start with y, the question, that is a, the value of the integral along this y equal to x. Now if y equal to x, dy equal to dx. Now we also know that z is equal to x plus iy, which means dz is equal to dx plus I dy. Now in this dy we will replace it with dx because dy equal to dx, so dz will be equal to dx plus I dy, I instead of dy dx, so that's equal to dx into 1 plus I is nothing but the dz. Okay, now we need z equal to 0 to z equal to 1 plus I. We are writing it in terms of x, so z starts from 0 to 1 plus I. Here x value is 0, here x value is 1. So when z changes from 0 to 1 plus I, the value of x changes from 0 to 1. So we can rearrange or rewrite this integral use such as integral x equal to 0 to x equal to 1 x square minus I y equal to x, so x square minus ix dz, we have to replace it with dx into 1 plus I. So this is equal to integral from 0 to 1, 1 plus I can be taken out, x square minus ix times dx. Now 1 plus I out, x square integral is x cube by 3, that is from 0 to 1, minus I into x square by 2, that is from 0 to 1. So 1 plus I into, substitute for the x, that is 1 by 3, this is minus I, and again 1 by 2. So Now what we can do is multiply the each term. So starting with 1, so this is equal to 1 plus I into 1 by 3 minus I by 2. So that gives us 1 times 1 by 3 is 1 by 3 minus I by 2 plus I by 3 plus I times I is minus 1, minus of minus plus, so 1 by 2. So the real term is 1 by 3 plus 1 by 2. Imaginary term is I by 3 minus I by 2. So this is 5 by 6 the real term, and the imaginary term is minus I by 6. So this is the integral. See here we have the equation y equal to x square, dy is equal to 2x dx. Okay, now again we can write z is equal to x plus iy, which means dz is equal to dx plus I instead of dy 2x dx. This gives us dz is equal to dx into 1 plus 2ix. So first part is over. Now our integral from z equal to 0 to z equal to 1 plus I x square minus iy times dz. This is the question. Now we also know that when from here z is equal to x plus iy, when z moves from 0 to 1, x value moves from again 0 to 1, sorry, this is 0 to 1 plus I, x is moving from 0 to 1, and take this as 0 plus 0i to 1 plus 1i. So this is x value 0 to 1. So this integral can be changed into x equal to 0 to x equal to 1 x square minus I y is equal to x square into dz. What is dz? That is dx into 1 plus 2ix. Now here you can either take x square common and then later multiply, but let us do the multiplication now. So that's equal to, let's multiply these two quantities. So x square into x1, that is x square. X square into 2ix is 2ix cube plus 2ix cube minus ix square, then minus I into I is plus I, x square into 2x cube, so plus 2x cube. Right, now this integral with respect to dx from 0 to 1. So each term we can take x cube by 3, again 2i into x to the power 4 by 4 minus I into x cube by 3 plus 2x to the power 4 by 4. Now this all integral limits from 0 to 1. 0 you need not consider because it's the lower limit, there is no other terms coming which gives us other value other than 0. So x cube, so 1 by 3 plus 2i 1 by 4 2i by 4 minus I by 3 plus 2 by 4. 1 by 3, this is 2 by 4 is 1 by 2 plus 1 by 2 plus I by 2 minus I by 3. This gives us 5 by 6 plus I by 6. Now from this you can understand that f of z that we were dealing with, f of z which is given as x square minus iy, is not analytic. If it was analytic, both the integral should have been the same answer. Here we have the second type, integral over c f of z dz, where c is the circle of with radius z minus x plus iy mod equal to r. This gives the magnitude and that is equal to r. Actually it is the mod. Okay, now some points over here, this is the r, then we can write now this is point is x plus I y. Okay, that's the center. Now what we can do is can find z, that is equal to r e to the power I theta. So dz will be equal to r, this is dz with respect to d theta, so r e to the power I theta into I d theta, so that's equal to I r e to the power I theta d theta, that is the dz. So integral over f of z dz, you can replace dz by I r e to the power I theta d theta. Then the integration will become integral from now this theta varying from some points, let us say theta 1 to theta 2, f of theta d theta. Now let us understand what is clockwise and anti-clockwise integration. Now anti-clockwise means from this is 0, this is pi, this is pi by 2, this is 3 pi by 2. So anti-clockwise from 0 to pi, this is in this direction, anti-clockwise. Clockwise direction is just the opposite, clockwise. Okay, so anti-clockwise means from 0 to pi, and clockwise is in this direction. This is clockwise. So anti-clockwise direction means the theta 1. So if I write anti-clockwise, then the integration anti-clockwise from 0 to pi means theta 1 equal to 0 and theta 2 equal to pi. Clockwise means the theta 1 will become pi and theta 2 becomes 0. Similarly, if it is from pi to 3 pi by 2 or pi by 2 to pi, it all depends on whether it is integration is taken over clockwise or anti-clockwise direction. Here in general our complex number, the argument means the theta angle made by the complex point or the complex number. So for example, if this is the complex number, z is equal to x plus iy, this is the argument, and this is with respect to, argument is with respect to x-axis or the real axis. So any integration or integral will be in default we will be taking it from in an anti-clockwise direction. In anti-clockwise direction, because theta is defined in that manner. Theta is from this point, how much is the angle made by this point z. Okay, now so let's write the same things. In upper half, this is the upper half above the x equal to 0 line. Now in the upper half, this is 0, this is pi, and this is again this bit 0, and this is 2 pi. So upper half means anti-clockwise. Generally it should be from 0 to pi. Lower half means it is from pi to 2 pi. Lower half means here, anti-clockwise direction. Now in the question, sometimes in the question it will be defined the integral value. Integration should be in clockwise direction. Integration in clockwise. In clockwise means just the opposite. Upper half means pi to 0. Lower half pi to 0 or pi to 2, pi to 0, and in the lower half it is from 0 to pi. Or you can take 0 to 2 pi to pi. Either this two things you can take, both are same, there will be no change. This is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is again 2 pi. Okay, now what is the value here? This point is where y equal to 0, that means x equal to 1. This is a point where x is 0, y is 1, that is I. This is a point where x equal to minus 1. This is a point where y equal to minus I. When I write the z, the complex number z equal to x plus iy, the values when z is equal to 1 means this is the point, that is 0, pi theta equal to 0. When z equal to say for example minus 1, which means theta equal to pi. When z equal to I, which means theta equal to pi by 2, and when z is equal to minus I, theta is equal to 3 pi by 2. Now this is the same thing, you can get it from e to the power I theta, which is equal to cos theta plus I sin theta. Then substitute the value for theta equal to 0, you will get this is equal to z equal to e to the power I theta. So put each value of z at theta equal to 0, theta equal to pi, theta equal to pi by 2, and theta equal to 3 pi by 2. You are going to get the values such as 1, minus 1, I, and minus I. Evaluate the integral along the curve C, z minus z square dz, where C is first one. We have to evaluate the first one and 2. Take the first one. C is upper half of the circle with z minus 2, mod z minus 2 equal to 3, which means the radius is equal to 3. Okay, now taking the first part, z is equal to r e to the power I theta, which means dz is equal to r e to the power I theta into I d theta. Okay, now what is r equal to? Radius equal to 3. So our z value is equal to 3 e to the power I theta, and dz is equal to 3 I e to the power I theta d theta. Okay, now the integral is along the curve C, z minus z square dz. Now that's equal to, let's write here, integral z is 3 e to the power I theta minus z square will be equal to 9 e to the power 2 I theta. This one into dz. What is dz? 3i e to the power I theta, 3i e to the power I theta d theta. So that's equal to 3 times 3, that is 9 I e to the power I theta, 9 I e to the power 2 I theta d theta, minus this is 27 times e to the power 3 I theta here one more I is there. Okay, d theta. Okay, that's accounts for the two terms. Now integral 9i times e to the power 2i theta. This integral is 2 to the power I theta by 2i, that is the integral of the first term. Then this value is from let us put the limits later. Then minus plus minus 27i e to the power 3i theta divided by 3i again. Now what is the limit? Upper half of the circle. Upper half of the circle means you can take from 0 to pi, 0 to pi, which means it is in anti-clockwise. If it is not given in the question, you should always go with anti-clockwise, because your z value starts from in this direction. The angle we will be talking is theta. It will be with respect to x coordinates. That's why it starts from anti-clockwise. Okay, so it is from 0 to pi, again 0 to pi. Now here first term we can go with the upper limit first. 9 I and I gets cancelled, so 9 by 2 into first let us put the upper limit 2I pi. 2I pi means 0, so that is 1. Why? E to the power I theta means cos theta plus I sin theta. Theta term is pi is sine term goes to 0, so cos 2 pi is 1. So 1 minus again the terms gives us e to the power 0, so again 1 minus 1 plus 27 by 3 is 9, so minus 9 into go to the upper limit e to the power 3I theta, so it becomes cos pi, that is minus 1, again here with 0, so that's again minus 1, so this term goes to 0, and here we have minus 9 into minus 2, that is 18. So changing the limits here, the integration will be constant, the limits will vary, so it starts from, so here we have lower half of the circle, lower half of the circle, that is z minus x plus iy equal to 3. Now lower half means the integral value limits are from limits anti-clockwise in lower half is from pi to 2 pi. So let's change this limits. So 9I e to the power 2I theta by 2I from pi to 2 pi minus this one can be written as 9I e to the power 3I theta from pi to 2 pi. So 9 by 2 e to the power 4I pi, e to the power 4I pi minus e to the power 2I pi minus this one, there won't be I, so 9 into upper limit is e to the power 6I pi minus e to the power 3I pi. The first term e to the power 4 pi and 2 pi gives 0, minus 9 into first term goes to e to the power 6, so that is 1, e to the power 3I pi is minus 1, so that's equal to minus into 9 into 2, that is minus 18. Integral 2z plus 3 by z dz. The integral value is from to be taken from in the clockwise direction in the upper half of this circle. Circle is given as mod z equal to 2. So in general, what is the formula for circle? Z minus x plus iy equal to r, where this is the center. Now in this case the center is 0. Okay, so z is equal to 2, the radius, e to the power I theta. Dz will be equal to 2 I e to the power I theta d theta. Okay. Now the integral 2z plus 3 divided by z dz. Now substitute for what is z. So integral, and also we can write the limit since it is in the upper half clockwise. It is from pi to 0. So pi to 0, z is 2 into 2 e to the power I theta divided by plus 3 into 2 e to the power I theta. Now we need dz. Dz is 2i e to the power I theta d theta. Okay, whichever is possible you can remove. Here we have 2 e to the power I theta, 2 e to the power I theta. So integral from pi to 0, 2 times 4 e to the power I theta d theta plus I is missing, so I times 4, then 3i, okay, 3i, that is integral 3i d theta. Okay. Both the integrals are from pi to 0. Now 4i e to the power I theta, integral is e to the power I theta divided by I from pi to 0 plus 3i theta from pi to 0. Now I gets cancelled. 4 times e to the power I theta, putting the upper limit first, e to the power 0, that is 1, e to the power I pi, that is minus 1, so 1 minus 1 plus 3i 0 minus pi, so 4 times 2, that is 8, minus pi into 3i, that is minus 3i pi. Integral over c mod z dz. It is in the left half of the circle. That means this is y-axis, this is x. So left half of the circle means this is the area where to the left of y-axis, that is x equal to 0 axis. Now from minus I to plus I, so this is minus I, this is plus I. This is 0, this is pi by 2, this is pi, 3 pi by 2, and this is 2 pi. And if you substitute for e to the power I theta, that's equal to cos theta plus I sin theta. So substitute for the theta value here, you will get the value of z equal to e to the power I theta. Now coming to what is z, the mod z, here the value is given mod z equal to 1, which means r e to the power I theta. So r value is 1, so e to the power I theta. Now dz is equal to e to the power I theta I d theta. So integral mod z dz, so mod z equal to 1, when dz will be equal to e to the power I theta I d theta, e to the power I theta I d theta. Now we want the limits of the integral. So it's given as minus I to plus I. So minus I means 3 pi by 2, plus I is pi by 2. So integral is I times e to the power I theta by I from 3 pi by 2 to pi by 2. Now that's also tells us e to the power I theta from 3 pi by 2 to pi by 2. Substituting the upper limit, e to the power I pi by 2 minus e to the power 3i pi by 2. So e to the power I pi by 2 is I, that is plus I, minus e to the power 3i pi by 2 is here minus I. So plus I minus minus I, this gives us 2i. So integral is 2i. Integral or C log z dz along a circle with the mod z equal to 1. Now let's start with what is z. Z is equal to r e to the power I theta, which means r is equal to 1, which implies z is equal to e to the power I theta. So dz will be equal to e to the power I theta times I d theta. Now the integral, integral is from along this curve, that means along the circle. So you can take the integral from 0 to 2 pi, the log z dz, that's equal to integral from 0 to pi log of z is e to the power I theta times dz is e to the power I theta I d theta. So log e to the power I theta is I theta, so that's equal to integral from, this is 2 pi, 0 to 2 pi I theta times e to the power I theta I d theta. So that's equal to minus 1 integral from 0 to 2 pi e to the power I theta or theta e to the power I theta d theta. Now we can write theta e to the power I theta. So this is integration. So let's take this is u v integration. Now let's take u as theta and v as e to the power I theta. So theta e to the power I theta. First derivative is 1, second derivative is 0. E to the power I theta, first integral is e to the power I theta by I. Second integral is e to the power I theta by minus I into I, that is minus 1. So this is plus, this is minus. So integration is theta e to the power I theta by I, minus of minus plus e to the power I theta. Now substituting the limits, theta e to the power I theta by I from 0 to 2 pi plus e to the power I theta from 0 to 2 pi. So first one, going with the upper limit, 2 pi by I, 2 pi e to the power I times 2 pi, that is cos 2 pi, that is 1, minus 0 plus e to the power 2 pi is 1, 1 minus e to the power 0 is again 1, so that's it. So here this is the second term is 0, this means 2 pi by I, dividing and multiplying by I on both sides, you get I here, so minus 2 pi I. Yeah, here minus 2 pi I, here is a term minus 1 which we have to add with this minus, so this is minus 2 pi I into minus 1, that's equal to 2 pi I. Evaluate the integral e to the power z dz along the counter shown in the figure. The counter shown in the figure is the mentioned in color red. Okay, so you have to find the integral along a to b and from b to c. Now e to the power z, is analytic. So now coming back to the question, integral e to the power z dz. Now let's understand z is equal to x plus iy. Now dz is equal to dx plus I dy. Now integral from a to b f of z dz plus integral b to c f of z dz is equal to integral from a to c f of z dz, because e to the power z is analytic. Now we need to find integral from a to c f of z dz. Now a to c means the value of y is equal to 0 from when moving from a to c. You see the second coordinate is 0, so y value is 0. So z is equal to x plus iy, means z equal to x and dz equal to dx. Now the integral from a to c, so which value we have? Only x value. X is moving from 0 to 1. E to the power x, instead of z we have x, z equal to x, e to the power x dx from 0 to 1. This gives us integral e to the power x is e to the power x, and the limits are from 0 to 1. Put the first upper limit, e to the power 1 minus the e to the power 0, that's equal to 1, sorry, e minus 1. Find the integral or this curve z dz along the curve as directed in the given figure. Now the curve is directed in color red, so we have to integrate along the path which is mentioned in the color red. So that is from A to B, then to C, and then to D. Now according to the theorem, we have if the function f of z is analytic, then the integral from A to B f of z dz plus integral from B to C f of z dz plus integral from C to D f of z dz. This is what we need. This will be equal to integral from A to D f of z dz. So instead of going from integrating 3 times, we can integrate from A to D f of z dz. So z is equal to x plus iy, and along A to D we know that the y-axis is 0, so y is 0, so az is equal to x and dz will be equal to dx. So integral z dz from A to D, so A to D f dz is equal to the x value is ranging from 0 to 2, so 0 to 2 x dx, because z is x and dz is dx, so that's equal to x square by 2 from 0 to 2, and that's equal to 2 square by 2, that's equal to 2. Cauchy integral theorem. Now let us consider a simple closed counter. Simple closed contour, then and we have a function f of z which is defined in that particular contour. So for example, we have something like this. This is the domain or the contour C. Okay, now if f of z is analytic, if the function f of z is analytic, then f dash of z would exist, and both this f of z and f dash of z is continuous in the in and on the contour. Right? So now what does this mean if it is analytic? Now when you take the integral over this contour C, f closed integral f of z dz will be equal to 0. This means that the integral is independent of the path followed. So independent of path. It depends only on the endpoints. Depends only on endpoints. It's similar to our point function. Point functions such as potential V or the internal energy U. Okay, all these are point functions. Here let us consider two contours. Let this be C and then let this one be C1, what is inside. Okay, now they are called connected counters. Connected counters. Okay, now we have a function f of z which is analytic in the region so let us we have to define the region between C1 and C. What is the region between C1 and C? That is given in the color yellow. So here the yellow color we have defined here is the counter where our function f of z is analytic. So when you integrate over this contour closed integral or f of z dz, now this closed integral includes, so this includes both c and c1, both c and c1. So the closed counter including this c1 gives us 0. This is value is equal to 0. Now and we also have to understand that apart from in the white region, the f of z is not analytic. That means if you consider the region white, that means if you consider the closed integral over the counter c, only c, f of z dz is not equal to 0. Only when you consider f of z in the analytical part it will be 0, because this integral will be behaving in this way only if there is no discontinuity. It should be analytic. The f of z has to be analytic. Then the integral goes like this: integral over the counter c f of z dz plus, now there is a discontinuity. Let us just define two lines here which moves from a to b, then back to b to a. So this is in enlarged way. So this is a, this is b, this is b, and this is a. Now the closed counter will be over this curve c from one end, then like this it will be in this way coming to this and then moving back. Okay, so we have taken one complete rotation from in the c plus integral from a to b f of z dz plus now the counter c1. So integral over the counter c1 f of z dz plus integral over the from, now it is from b to a, b to a f of z dz equal to 0. So this is one thing. Now we know this is integral from a to b and integral from b to a f of z dz. This accounts to both 0. So integral over c f of z dz plus integral over c1 f of z dz equal to 0. Now you understand that this is c is in the clockwise direction, so this is in anti-clockwise direction, and while this integral f of z c1 is you see this is in the clockwise direction, it moves in this direction, while the counter c is in the opposite direction, that is the anti-clockwise. So this is clockwise. So together we can write in this way: integral over c f of z dz is equal to integral over c1 f of z dz. If you can put a minus sign, this will become anti-clockwise, and you can write c1 equal to minus of f of z dz in the clockwise direction, sorry, anti-clockwise direction. So you will get integral c f of z dz equal to integral over c1 f of z dz. Now here let us take, there are c1, c2 and c3. There are three contours where it is function f of z is not analytic, and this is c where the function is analytic. So let us consider the c, the contour which is where f of z is analytic, and the contour c1, c2 and c3 where f of z is not analytic. Then what we can do is the integral over the contour f of z dz, that means in the analytical region, will be equal to integral over the contour, so c1 f of z dz plus integral over c2 f of z dz plus integral over c3 f of z dz. We are writing the integral of this analytical function as the sum of the integral over the curves c1, c2, c3 where it is not analytic. Now if you see, let us give the terms here. Let it be z equal to a, z equal to b and z equal to c, assuming that at z equal to a, z equal to b and z equal to c are points where the function f of z is not analytic. So we have got 3 points where the function is not analytic. Then the integral over this region, that is yellow region, integral over the yellow region f of z dz will be equal to integral over c1 where z equal to a f of z dz plus integral over c2 where z equal to b f of z dz plus integral over c 3 where z equal to c f of z dz. Cauchy integral formula. So let us assume that we have a function f of z by z minus a. This is our function, and we need to find the points where the function is not analytic. Now by looking at this, the function will go to infinity when z equal to a. When z equal to a, function f of z divided by z minus a is not analytic. It is not analytic because it is not continuous. It's not a continuous function at z equal to a. Now how do you get this? We get it by putting the denominator of the function f of z, we will put it equal to 0. Now we will get those points, or what you call it as the roots. So the poles will be there, Poles, they are called poles. Poles means the roots. So you get the roots. That roots is nothing but the poles. Okay. uh, so so these poles, either it will be inside the contour, or outside the contour. Now if it is inside the contour, we need to address that point, or if it is inside the point contour, they are called singular, and if it is outside, we need not bother. It will not be considered because it is always outside the domain. Now what does that the Cauchy integral formula says? The integral over the curve C, f of z divided by z minus a dz is equal to integral over C1, where the function is not analytic, f of z divided by z minus a dz. Now this is equal to, we have to be, this is equal to 2 pi I into f of z at z equal to a. Just put find f of z at z equal to a. This will be the answer. Now suppose if there are two poles, say for example f of z divided by z minus a into z minus b, z minus a into z minus b. Then we have the poles at z equal to a and z equal to b. That means at z equal to a and z equal to b, the function is not analytic. So the integral f of z divided by z minus a into z minus b dz will be equal to, there are two contours, C1, C2. C1 for z equal to a, let us write C1 for z equal to a, and C2 for z equal to b. Okay. So f of z, so it will be something like this. You have a contour, here you have non-analytical region, this is another analytical region, this is C1, this is C2. This is the entire one is C. So the entire one C is equal to integral over C1 f of z divided by z minus b divided by z minus a. We are just writing it such that the denominator comes where separately writing z c1 and c2 plus integral over c2 f of z divided by z minus a divided by z minus b. This is equal to write down the function 2 pi I into f of z divided by the function is z minus b at z equal to a plus 2 pi I into f of z divided by z minus a at z equal to b. So this is the what Cauchy integral formula says. Find the integral z by z square minus 3z plus 2 dz, and this is integral over the curve C, and what C is given by is a circle z minus 2 equal to half. So we can write the equation of the circle in a complex form, z minus x plus iy mod equal to half. So we know that the radius is equal to 1 by 2. Now what are this x and y here? So here z minus 2, so there is no complex term here, so y axis is 0, so x is 2. So somewhere here we have 2 comma 0 as the center, and the radius what we know from 0 to this point is half, just the half of the radius. Now we need to find the points where the function is not analytic. So these are the 2 points where we have to write what is z equal to, and there are 2 points where it is not analytic because this is a quadratic equation. So putting z square minus 3z plus 2, that is the denominator, equal to 0, we can write this as z minus 1 into z minus 2 equal to 0, which implies z equal to 1 and z equal to 2. This is z equal to 1 and z equal to 2 are the points where the function is not analytic. Now you got the points z equal to 1 and z equal to 2. Now we need to know that these points z equal to 1 and z equal to 2 lies inside the this C. This is C, this is this will be C1, this is C2. We want to know whether this is inside the C or outside the C. Now to that we have to substitute in this equation counter z minus 2 is less than or equal to half. This quantity z minus 2 mod has to be less than or equal to half, only then we can say that it is inside or outside. If it is less than half, it is inside. If it is greater than half, it is outside, definitely outside this radius. So z, let us first put z equal to 1. So 1 minus 2, 1 minus 2, is it less than or equal to half? No, it is not less than or equal to half, because 1 minus 2 is 1. And now we have 2 minus 2, this is z equal to 2. Is it less than or equal to half? Yes, 0 is less than or equal to half. So z equal to 2, z equal to 2 is inside, and this C2, which is z equal to 1, is outside the contour, somewhere here, it is not inside. So we need not consider this particular point. Okay, this is outside the contour. Now we can integrate. What is the integration? Integral z divided by z minus 1 into z minus 2 dz over the c is equal to integral over c1 at z equal to 2. So z minus 2 will be in the denominator. In the numerator we have z divided by z minus 1 dz. This is equal to 2 pi I times, now we need to write the numerator here, that is z divided by z minus 1 at z equal to 2. Now substitute for z equal to 2 here, which gives us 2 pi I into 2 divided by 2 minus 1 is 1, so that's equal to 4 pi I. So this is the integral value. Yeah, in this question somewhere here we will have 2 comma 0, and towards the left side we will have 1.5 comma 0, because the radius is 0.5, and towards the right side we will have 2.5 comma 0, which is this point. This is another radius. So now the denominator, that is z square minus 3z plus 2 equal to 0 implies z minus 1 into z minus 2 equal to 0, which implies z equal to 1 and z equal to 2. Now z equal to 1 means x plus iy equal to 1, and here x plus iy equal to 2, which means x equal to 1 and x equal to 2. Now x equal to 1 means somewhere here you have the point x equal to 1. Now this point is outside the contour C. Our contour is only what is inside this circle, so in x equal to 1 is outside, and this can be neglected. And where is x equal to 2? X equal to 2 is somewhere here. So here is x equal to 2, and this is point is what we need. At this point the function is not analytic, so this is a singular point. Here are two questions that you can consider doing as practice work. 2z plus 1 divided by z square plus z, mod z equal to half. Second question, 4 minus 3z by z into z minus 1 into z minus 2, both you find the integral over the C. The curve is given by, and the second case curve is given by mod z is equal to 3 by 2.